All right, guys, so let's look at the next student task called rotations and distance. All right, so we're dealing with circumference. So before we get started, I'm going to write the formulas at the top corner so you guys can remember or recall or reference to it when solving these math problems. So R stands for radius. And the circumference formula that includes radius includes 2 times pi times r. You could also write it like this, 2 pi r, because you don't actually need to put the multiplication symbols. All right, I'm just doing that so you guys can understand at home that multiplication is being, talked about, or is basically being used with these equations or formulas. All right. And then D is equal to diameter. And the formula for circumference using diameter is 2 times pi times, not 2. Oops. It's going to be pi times D. I'm sorry about that, guys. Pi times diameter. And can also be representing as R, can be represented as pi times D. All right. So, and last thing I want to annotate is pi is equal to or about 3 14/14. Okay. So it says a wheel has a diameter of 20.8 inches. Okay. So a wheel has a diameter of 20.8 inches. Okay, so before we even start, which formula are we using? Are we using the one with radius or diameter? If you guess diameter, you are absolutely correct because it gives us diameter, okay? So I want to plug that in, which is 20.8 or 28/10 times pi. Okay. So there's ways that we can solve this, or we could leave our answer in terms of pi. If we were to leave our answers in terms of pi, we could just leave it like this, 20.8 pi. If we wanted to solve it, we would have to multiply 20 times 20.8 times pi. Okay, so 20.8 times pi would give me about 65 3/10 inches. Okay, that's for one rotation. Remember, circumference is going around the circle. Okay, it goes around the circle. But let me not draw those squiggly lines that many times because it's one rotation around the circle. So I'm going to draw a circle. Of course, I don't want to let me change my color, but there we go. So I'm going to draw a circle. Okay, so we found that circumference of this car wheel, correct? And it asked us to do one rotation, which would be the area of circumference. Well, then it asks us, what would we do with 5 rotations? So just think about it. What would we have to do if we go around this circle 5 times? So 1, 2, 3, 4, 5. So what would we do if it goes around the circle 5 times? Think about it, 5 times, 5 rotations. If you guess to multiply that answer by 5, you are absolutely correct. So you could write down 65 3/10 times 5 because that's indicating the 5 rotations. And it would give us 326 56,000 inches. Okay. If you wanted to round it up to the nearest tenth, you can and put 6/10. That's fine with me. We're just trying to study a skill today. All right. So what will we do? Like, okay, so for the next one, it'll say, well, what will we do about 30 rotations? Okay. Now, guys, do you think I want to draw this 30 times? No. What can we do? Okay. If you guess, we're going to multiply 65.3 and 65 and 3/10 times 30. You're absolutely correct. Okay. So 65.3 or 65 and 3/10 times 30 would give me 1,959 inches. Okay. So for part B, it's asking us to write an equation relating the distance the car travels in inches C to the number of the wheel rotations. Okay, X. So what did we do here? Like, what did we figure out? Like, how can we develop the equation? Let's think about our process, right? The first thing we did was we took the diameter and we multiplied it times pi, correct? So let's write that down. And although it gave us the circumference, which was equivalent to the first rotation, what do we do with this value after we did the first rotation? So what did we do? We multiplied it by any given number or rotation number. So they said let X represent the rotation. So we multiply that times X. And that was equivalent to our distance. Okay. So it's going to be 20 and 8/10 times pi times X, which is the number of rotations, and C will give me the distance traveled. All right, let's move on to part C. It says, about how many rotations does the car wheel make when the car travels 1 mile? Explain or show your reasoning. Well, first of all, you need to figure out, well, how many inches are in 1 mile? Okay, so you have to figure out how many inches are in 1 mile. So we know that, hold on just a second, I just want to make sure my number is right. How many inches in 1 mile? And there are, it's pretty big, 63,360 inches in 1 mile. Wow. Okay. So it gives us a value. Now, I don't know if you guys can recall this from Unit 2, but if you could recall this if you can recall this equation set up from Unit 2, this is kind of like a proportional equation, okay? So we can use this exact equation to help us solve, or to help us even figure out how to solve this, all right? So let's say it gives us a distance, a given distance, which what's missing is how many rotations, which this would be X, and what is given to us is C. So we'll do 20 times 20 and 8/10 times pi times, and make that dot big, X is equivalent to 63,360. Okay. So if you guys can recall from Unit 2, we need to isolate this variable. Now, true, pi is not it represents a value, okay? But we know what the value is. We even know what this is equivalent to. We know that this is equivalent to 65 3/10 inches times x is equal to that. Okay, so that's another way we could write that. Okay, but we want to isolate the variable. In order to isolate the variable, we need to utilize the multiplicative inverse and divide both sides by that. Okay, so when I divide both sides by, and you guys, I'm using the calculator. You guys can use a calculator at home. We are dealing with pretty big numbers today. So 360 divided by 65.3. All right, we could put that it's about, this is the number that it gives me though. I'm gonna write down a number that it gives me. And let me write that in a different color so you guys can see it. I hate that it doesn't give me so much room to write, but we're making it work. So it's going to give me about, and I'm around to the nearest thousands. It's going to give me about 970 and 29 thousandths. Okay, rotations. Now, let's talk about a full rotation. Would this be considered a full rotation? No, it would not be considered a full rotation, okay? So I will put, if I had to write an answer, I will put about 970 rotations. Because remember, if we was to try to go over it to try to accommodate this decimal value, then we'll have to stop like right at the beginning of the rotation. So it's not a full rotation, but you can at least get 970 rotations, but you wouldn't be able to fulfill the decimal. Okay. So now let's move on to the next one. Okay. A bike wheel has a radius of 13 inches. Now it gives us a radius instead of a diameter. All right. So we're going to plug that in to the formula, which is 2 times pi times r has a value, which is 13. Now, I know when I was in school, I used to just automatically multiply the 2 times the radius to figure out what the diameter is. And it's like 26 pi. And if you wanted to find out the exact answer, or not the exact answer, but you get, multiply it. So it'd be 3.14 or 3 and 14 thousandths times 26. And it'll give me 81 and 64 thousandths. Oh, no, it's hundreds. I'm sorry about that. So one rotation would be 81 and 64 thousandths or hundredths inches. Okay. So that's for the first rotation. So then I could take this number, put this right here so y'all can know that equals that. So then I'm going to take this number and I'm going to multiply it times 5. I'm going to write that down instead of just tell y'all, because I don't want to be like, hey, where did this number come from? No, so I'm going to multiply that number times 5. And that's going to give me 408.2 or 408 and 2/10. And then I'm going to multiply that same number times 30. All right, it's going to give me, oops, I should have never put a comma. Let me take that back. I meant to put an equal sign. It's going to give me 2,449.2. And I forgot to put my units, so put inches. All right. So for the next one, it's the same. It's the exact same thing. Okay. we want to write the equation, which the equation could be, and I'm going to write it different this time. I'll write it like this. All right. So it could be 81 64/100 times the any given value of the any given number of rotations, because the rotations is represented by x, will equal the distance. So then for the next question, it gives us a distance. It gives us the value for distance, but it's asking us how many rotations. So we're going to do 81.64 or 6400. So I'm making my multiplication symbol bigger. X is equal to 63,360 inches. All right, so I want to isolate the variable, which I'm going to divide by the coefficient on both sides. And when I do that on both sides, which, like I said, I'm using a calculator, so you could use one too, because we're dealing with some very big numbers this lesson. And it should be, I'm going to write down the exact number. Well, not the exact number it gives me, but I'm going to write down the decimal value that it gives me, and we're going to talk about it. So just like the last problem when it had that decimal, we want to count the full rotations. We don't want to just count, just start up, because that's not really a full rotation. So we have to pick, right? If we had to pick, okay, it would be about 776 rotations. Okay, because remember, we want to count the full rotations. We don't want to count just like they got it partially done. We want to count the full rotations, okay? So we showed our reasoning for these questions, okay? Which, if you have the option of showing your reasoning, guys, if you're not good with explaining things, feel free to do that, okay? So if you have any questions about this student task or this student activity, make sure you visit your manager's Google session. So I'll see you guys in the last student task, and yeah.